Okay, so what we're going to be talking about today is starting our unit on series and sequences. So today we're going to be talking about sequences, okay? So sequences is basically about finding patterns and sequences of numbers and how we utilize those to find other values in the sequence, okay? So sequences, or an ordered list of numbers, are very important in math, both theoretical and applied. A sequence is formally defined as a function that has its domain set 1, 2, 3, ... n being some specified value, okay? So let's say I have a sequence that's defined by the equation a of n equals 2n minus 1. And I want to find the first three terms in the sequence, okay? This is actually pretty simple because all we're doing is we're using substitution, okay? Now, see this notation? A sub 1, that's how we say it. Sub means subscript, okay? Normally, how we're used to seeing it is A sub n. A sub n means your current term, okay? Now, I want you to pay close attention to what the n values are. That becomes very important in how we figure out the values in our sequence. So if I want to find my first three terms, I want to find A sub 1, A sub 2, and A sub 3, okay? What is n equal to in A sub 1? 1. So if I want to find the first term in the sequence, I'm using my formula that's given to me. What is n again? 1. So we're going to plug it in. I substitute 1 in for n. So A of 1 equals 2 times 1 minus 1, which is equal to 1. Getting it? Not difficult. A sub 2, what's n? 2. So I'm going to use A of equals, good. So it's just substitution, right? Paying attention to what that value of n is. That's very important for the further we get in this lesson. So this is 3. Now what? A sub 3, which is going to be A of, which equals 2 times 3 minus 1, which is 5. So there's your first three terms, 1, 3, and 5. How'd we do? Okay. So we're going to evaluate the sum. What's sum mean? Add, addition, right? By the summation 1 to 5 of A sub I. Okay. Has anybody ever seen that symbol before? You've seen it, but you don't know what it is, right? Okay, so what this symbol is, you can see it as sigma or summation. Okay, sigma or summation. Summation, what's the first part of that word? Sum. So you're probably going to do what? Add. All right, now here's the key to this. The variable is what? I. So everywhere you see a variable, A sub I, we're going to plug in a value, okay? The values that we're going to be plugging in are going to go from our lower bound, which is 1, all the way to our upper bound, which is 5, okay? So my first term is going to be A sub 1. Summation, what am I going to do? Add. Plus, what's the next term going to be? A sub 2. Plus, next one, plus, plus, and I'm going to stop there. Why am I stopping there? It goes to 5, okay? That's my upper bound. That's summation. That's what we're plugging in for. The variable is I, right? So if I starts at 1, ends at 5. We're plugging in for I, okay? Summation, very difficult? It's not bad, right? It's just plugging in. Okay. So let's look at the next one. I'm sorry? That's it. So sequences can also be described using recursive definitions, and this is really important, okay? Recursive is going to be a big thing for this unit. So make sure that whenever we see recursive or recursively or recursion, we think along the same lines. So sequences can be defined using recursive definitions. When a sequence is defined recursively, terms are found by operations on the previous term. So here's how we can remember recursion. How many of you have been to a wedding? And you know, when they stack up the glasses and they make the big pyramid, right? And then they pour sparkling soda into the top one. And what happens to it? It fountains down, right? It goes all the way down, and it trickles down into the next one. So that's kind of what recursion is. You take your first term, and it's going to trickle down into the next term. That term's going to trickle down into the next term, and that term's going to trickle down into the next term. So you're constantly just borrowing from the one above, okay? And it keeps popping it down. All right, so let's take a look at what that looks like. All right, so a sequence is defined by the recursive formula a sub n plus 1 equals a sub n plus 5, where a sub 1 equals 2. All right, something important we have to talk about before we go any further. Lots of n's there, right? You have to know what they mean. Okay, so a sub 1, you write this down somewhere. If it's at the top of your paper, if it's in the corner, you're going to box it, make sure you know it. This represents your first term. And that should make sense because what's n? 1. Okay? A sub n represents your current term. Okay? A sub n is your current term. What would a sub n minus 1 be? Not minus your first. You're kind of there, but if I'm thinking n is my current, n minus 1 would be, let's say my current number is 4. 4 minus 1 is, how are 4 and 3 related? What is 3 in terms of 4? The previous one. Okay, so previous term. And what about a sub n plus 1? The next term. And notice I'm saying term each time here. Okay, a sub n plus 1, a sub n minus 1, those are all terms. Okay, so these n's are really, really important when we're going through this. You got to pay attention to those. All right, so I have a sub n plus 1. What does that mean? The next term is going to equal a sub n, the current term, plus 5. Okay, with my starting value at -2. Okay, so I know a sub 1 is -2. I want to find the first 5 terms in this sequence. So now I want a sub 2. What's n if I'm looking for a sub 2? Think about it. That n plus 1 is now 2, right? What is n if I'm looking for a sub 2? 1. Okay, so a sub what? What's n? 1. A sub 1 plus 5. What's a sub 1? What's a sub 1? -2 plus 5. Okay, you have to be able to figure out what that value of n is going to be. That's going to be really important when we get to like the Fibonacci sequence. Okay, so this gives me a value of 3. All right, a sub 3. What's n? -2. What's n? Think about it, guys. A sub n plus 1. What would n have to be to make this whole thing 3? Think before you speak. 2, right? Because 2 plus 1 is 3. So now we're talking with n being 2. So a sub 2 is, what's a sub 2? 3 plus 5. You're constantly going back and finding n, okay? This says a sub n plus 1. Always be the different, okay? This is the formula going off of, n plus 1, right? If I want, say, the 19th term, what would n be? 18. Why?
Oh, because 1 has to equal.
Got it? Okay. All right, so this gives me what? 8. A sub 4. What's n? 3. N is 3, right? So what's a sub 3? 8 plus 5, which is 13. Okay. A sub 5. What's n? 4. A sub 4 is? Plus 5 is? What do you notice about the value that I'm constantly plugging in? It's from the one before, right? I took 13. Where did it come from? The one before. I took 8. Where did it come from? The one before. I took -2. Where did it come from? The one before. 3. Where did it come from? The one before. So the value I'm plugging in is the one from before. That's the point of recursion. Okay? You're taking whatever you got from the one before and you're plugging it into that formula. Okay? All right, so let's say I wanted to find a sub 20. Am I going to go all the way through this? No, there has to be an easier way, right? So I want you to think about this. I know what my first term is. I know I'm starting at a value of -2, right? What do you notice about my sequence here? What do you notice about my sequence? Goes up by 5 every time. So I know I'm starting at 2. I know I'm going up by 5 every time. I want the 20th term. So I want you to talk in your group and see if you can come up with a formula that will get me that 20th term. Okay? So, all right, what do you think? No? I want a formula. How would I find a sub 20, given what I have? A of 19 plus 1? No? -2 plus 5 times, they're saying 20. Okay, now I want you to think about this before I write that 20 down. If I put in 20, I already have my starting value, -2. That's a sub 1, right? Do I want to tack on 20 more 5s? How many do I want to tack on? 19 more 5s, right? I'm adding 5 every single time. How many 5s do I have to add to -2 to get my 20th term? I got to add 19 more 5s, right? I have to add 5, 19 more times to get my 20th term, okay? So there's a general formula here. Anybody think they know what it is? A sub n, because I want the current term, whatever that current term I'm looking for is, right, equals, is it -2 all the time in every single recursive definition I have? A sub 1, my first term, plus, okay, so that value of 5 is called our common difference, sorry, totally blanked. Common difference, okay? So that means it's the difference, what we're adding or subtracting every time, depending, okay? So common difference we write as D, and we'll talk about that tomorrow in depth, okay? And then 19 is going to be written as what? And -1, excellent. Okay, so if a sub 20, n is what? 20. And then 20 minus 1 gives me my 19. So this is your general formula. You have to have this memorized. So what I'd like you to do is put it somewhere on your paper, box it, and star it, and make sure you have it memorized. Okay? And this is for this type of sequence. Okay? Very important. So are you going to have to go through and do recursion to find these larger values? No, it would be silly to. If I wanted the 113th term, you're not going to do this 113 times, okay? You're going to use the definition. Okay, next one. You ready? Determine a recursive definition for the sequence shown below. Be sure to include a starting value. What's my starting value? 5. So that's what? How do I write that? A sub 1 means my first term, right? And we just talked about this. A sub 1 is 5. I want a formula for what? What am I looking to find from 5? I want a formula that's going to give me what? I want a formula that's going to give me 10. What is 10 in relation to 5? Okay, you're getting double it. Say it again. N plus 1. What does n plus 1 mean? The next term. All right, I want a formula that will give me the next term. Okay, so you have to be able to write these appropriately. So n plus 1 means your next term, right? So I know I'm starting at 5. How am I getting my next term? I need a formula that's going to give me the next term. Do I ever put 5 in a formula? Am I going to put 5 in the formula? Because am I going to be multiplying anything by 5 here? A1? A sub 1. Okay, well, let's write it down and see. A sub 1, what? That can't be my formula. Then I'm just going to have 5s all over the place. Give me more. Nope. Okay, let's see if it works. What's A sub 1? 5. So 5 times 2 is 10. That's going to give me the next term. Then I'm going to say 5 times 2 again. That's going to give me 10. So is that going to work? I want all of the terms, not just the next one. So is that going to be A sub 1? A sub n. Why is it A sub n? Right, it's the current term times 2. So if I'm starting with A sub 1, multiply that times 2. Then I want A sub 2, multiply that times 2, right? A sub 3, I multiply that times 2. Is that going to work? Okay, so you see where these n's become very, very important, why you have to understand them, okay? All right, so this is recursion, this next one. The formula is different, and that's okay. You're going to get all sorts of formulas. T sub n, what does that mean? Current term. Equals T sub n minus 1, what does that mean? The previous term. Squared plus 2, where T sub 1 is 2, so there's your starting value. I want you to find T sub 4. Okay, so go ahead. This is recursion, so this is just like exercise 2A. All right, so go ahead, check it with. Okay, guys, so we're starting with T sub 1. That's given, that's 2, right? The formula says T sub n minus 1. What does that mean? The previous term. So you have to use the previous term, okay? T sub 2 is the previous term, which is 2 squared plus 2, which gives us 6, okay? T sub 3, previous term squared. What's previous term? 6. Okay? T sub 4, what's the previous term? 38. Are you getting it? Better? You should have gotten 1,446. Okay? All right. Let's talk about Fibonacci. All right, so one of the most well-known sequences is the Fibonacci sequence. It's defined recursively using 2 previous terms. So not just the one before, but the 2 before, okay? So the definition is given below. I have A sub n plus 1. What does that mean? The next term equals A sub n, which is the current term, plus A sub n minus 1, the last term, right? The previous term. Okay. I'm given A sub 1 and A sub 2, okay? So A sub 1 and A sub 2 are what I'm going off of. Now, let's say I want to find A sub 3 to start, okay? Based off of this right here, A sub n plus 1, what is A sub 3? What is n for this value? 2. Does everybody see where I'm getting the n value? Okay, so that you need to be able to do for every single one of these to determine what to plug into the formula. So n is what again? 2. All right, so the next step is we have equals a sub n. What's n? 2. So what's a sub 2? It's given to us. What's a sub 2? 1. Plus. What's n again? Okay, so a sub n minus 1, or a sub 2 minus 1, which is a sub 1, we get what? 1. So a sub 3 is equal to 2. And I'm just going to write them down up here so I can keep them clear. Okay, a sub 4. What is n? Is it the same every time? No. What is n? 3. Okay. A sub n plus 1, a sub 4, n is going to have to be 3. Okay. So pay attention to what n is. You have to know what it is. So a sub n is going to be what now? A sub 3, which is 2, plus a sub n minus 1. What's n? Okay, so 3 minus 1 is 2. So a sub 2 is 1, which gives me 3. You just got to do it piece by piece. You have to know what n is. Okay, if you need to write it out, that's fine. Write it out. Okay, a sub 5, a sub n plus 1. What's n? 4. Okay, so I can even say 4 plus 1. If it's easier for you to see this way, we'll write it out once so you can see it. Okay, so we're going to use a sub n, or a sub 4, right, plus a sub 4 minus 1. Do you see what I did with the n, Cassandra? Okay, so if it works better this way, do it this way. Okay, so we have a sub 5 equals, what's a sub 4? 3. And plus a sub 3, which is, and that gives me a value of 5. Is it easier for you to write it in there with the n? Okay, then write it in there with the n. Okay, so let's see if you can find a sub 6. Okay, and again, if you want to write it out, that's fine. What is n going to be with a sub 6? 5. Okay, so if you want to write it out, write it out. I'm going to pause it here. Give it a shot. All right, so what you should have here is a sub 5 plus a sub 4, right? So a sub 6 equals 5 plus 3, or a sub 6 equals 8.
Yeah.
3 is a sub 4.
Oh, okay. So you don't just keep the 4.
No.
You have to go back.
Yes. Yep. All right. We got to move on, guys. We'll come back to this after. Okay, so you also have to be able to look at a sequence of numbers and figure out the explicit formula. Okay, so when I'm talking about formulas for this one, we're talking in terms of a of n. This is not recursion. Okay, this is just finding a formula that fits the sequence. Okay, so remember when I'm dealing with these types of formulas, these a of n's, the first value of n that I'm going to plug in is what? 1. And then the second one is going to be 2, and the third one is going to be 3. Okay, so just like when we talked about number 1, exercise 1A, you have the formula, you plug in 1 to find the first term, 2 to find the second term, 3 to find the third term, right? So we want to come up with a formula that fits this one. Okay, so a of n equals, I need a formula that's going to fit this. Keeping in mind that the first number I'm going to plug in for n is 1. Okay, what's my first term? 4. So I need some formula that when I plug 1 in is going to give me 4 for the first term. When I plug in 2, it's going to give me 5. When I plug in 3, it's going to give me 6, so on and so forth. Say it again. 3 plus n, or n plus 3, right? Will that work for me? Yeah, a of 1 is 1 plus 3, which is 4. A of 2 is 2 plus 3, which is 5. A of 3 is 3 plus 3, which is 6, so on and so forth. So that works. That's perfect. Nice job. Okay. All right, so let's see if you can come up with the next formula. Now, remember, it's not always going to be addition. Sometimes it's going to be multiplication. Sometimes it's going to be division. Sometimes it's going to be exponential. It just depends on the sequence. Okay. So let's see if you can figure out B. Yeah, B is definitely changing by multiplying by 2, right? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. But what's the formula for that? Okay, n times 2, let's talk about that. So 1 times 2 works, gives me 2. 2 times 2 works, gives me 4. 2 times 3 gives me, so does that work? No, it doesn't work. What is repeated multiplication? What's repeated multiplication, guys? Exponents, right? So we're talking about exponential here, okay? What's the base? What am I going up by? What's the base? 2 to the first power is 2 to the second power? 2 cubed? 2 to the fourth? So that works. Okay? One more of these, and then we're done for the day. What's the only thing that's changing here? The denominator, right? So real quick, what's the formula? Five over n. Only thing that's changing is n. N of 1 is 5, n of 2 is 5 halves, n of 3 is 5 thirds, n of 4 is 5 fourths. Okay? So again, your homework is pages 2 and 3. Do we have a minute? I have a minute. Don't put your stuff away yet. Let's look at exercise 5 real quick. Okay. Which of the following would represent the graph of the sequence a of n, a sub n equals 2n plus 1? All right, so we're talking about sequences, right? Sequences are values that I order into a list, right? Do I connect them? So I'm automatically going to get rid of 2 and 4 without even looking at what my explicit formula is, okay? What's the first value that we plug in for n? 1. Do I start at 0? So what else can I cross out? So my answer is 3. Okay. All right. Again, homework is pages 2 and 3. Weekly project 20 is due Thursday. I will see you guys tomorrow.